In this demonstration, what we want to do here is to show the difference in temperature control, heat control and glare control between two identical fabrics with one difference. One side is metallized and the other one is not metallized. We will also test the difference in performance between two identical white screens and the same, one side is metallized and the other side is not. We measure the heat gain, we measure the temperature control, the heat control with an infrared thermometer. We measure the light control with a lux meter. So what we will do first is we will start with the black standard screen, not metallized. We take a benchmark temperature in order to see what is the ambient temperature in the room, which is the temperature of the screen. The temperature of the screen is 76 degrees. We don't have the sun here, but we have a lamp, a halogen lamp, which gives a lot of heat and it gives a lot of light. And we will test the difference in temperature and the difference in light transmission if we put on the lamp. A black screen, not metallized, will absorb a lot of energy. So if we measure the temperature after 20 seconds, we will see that the temperature will increase dramatically. But first of all, let's measure the light transmission. At this moment, the light transmission times 10 is about 1000 lux. 1000 lux is coming through a black common screen, which is a very nice result because a black screen absorbs a lot of light, so you don't have a glare issue. But what you have is all that light being absorbed transforms into heat. So if we measure the temperature of the black screen, we see that the temperature has been risen to 160 degrees Fahrenheit because all the energy is being absorbed in the screen. Now we take the same screen again, but one difference, the back side of the screen is metallized. So if we measure the light transmission, we don't see a big difference because black screens are good for light transmission. We see a slight lower light transmission. But the big difference between a black screen and a black metallized screen is the heat absorption, because aluminum doesn't absorb energy, it reflects it back. So if we measure the temperature, instead of 163, we are at only 93 degrees Fahrenheit. So aluminum doesn't absorb, aluminum reflects energy back to the outside. But if you have an issue with heat, what you can also do is take a white screen, because white screens don't absorb the heat as well. But the white screens, they have another issue. They have translucent yarns which give a lot of glare. So we will start with the white screen to measure temperature and light again with the white common screen without metallization. And the first thing we can measure is the amount of light. Remember, the black screens, they were around 900,000 lux. And look what happens here. We're already at 5,500 lux, creating a very big glare issue. Temperature wise, it will be fine because a white screen doesn't absorb the energy, so the temperature is only at 95 degrees. But it transmits all the energy into the room and finally also creating a lot of heat over there. So a metallized screen is not only very reflective, a metallized screen is also blocking light coming through the yarns because aluminum is non-transparent. So if we measure the amount of light coming through, what we will see, instead of 5000 lux, we're only again at 1000 lux. So no glare issue, but glare control. Temperature wise, it will not be a big surprise, but the temperature is, as expected, 94 degrees Fahrenheit. So in the end, what we prove here is that if we take black or white screens, and if we go for the versions without metallization, what we see is that black screens, they absorb a lot of heat, so you have a big heat problem, 160 degrees Fahrenheit. White screens, a big glare issue. Light transmission was at around 5,000, 6,000 lux. If we take white and black screens, the two most extreme colors, but if we metallize the backside, temperature difference 0. Light transmission difference 0. So, because these are the two most extreme colors, what we want to prove is that there are color independent solutions that have the best of heat control, the best of light control, and still offer a beautiful view to the outside, regardless the color that you choose.